So today we're going to get some notes on the different parts of a quadratic function, or kind of how they look. Also, the different types of questions that we usually see with this unit. You got some of the ones where you have to FOIL, you got some of the ones where you got to do the X and do the factoring, but there are other types of questions as well. All right, so first, been a couple weeks, but we went to the gym, we threw some balls. Everybody remember what kind of path they took? What'd that shape look like? Yeah, so when you got, person and they throw a ball, it kind of makes a little bit of an arc shape or a rainbow shape. All right, what that curve actually will be called, that's a parabola. All right, but what they have, as I said before, they follow the path of a quadratic function. All right, A, B, C each have specific parts in a problem like that. And a lot of the problems you have are going to be like a ball thrown or a ball kicked or rocket or something like that. Okay? So we got to know kind of what the different parts are. First, for A is typically gravity. There are two different ways that can be shown. One is for when the units are feet. When the units are feet, you'll see the -16 there. Gravity pushes things down. That's why it's a negative number. Okay. Scientifically speaking, gravity is, I want to say it's like about -32 feet per second squared. More complicated than you need. The way the math works out, it ends up that an equation would use half of that. Okay. For meters, if everything was in meters in the problem instead of feet, it's usually -4.9 that you'll see in front. All right, but most of them, we're in America, most things are feet, so you'll usually see that -16 on these. All right, the B value is the initial velocity, and that's going to be in feet per second. If you got the -16, if it's a -4.9 there, that'll be meters per second, okay? So things are thrown, when they leave your hand, that's the initial velocity, the velocity at the start. So if you kind of throw it and it follows that rainbow kind of arc to it, at the top, it's got like no speed at all. That's what makes it start dropping. So B is what it is to start with. The problems that have rockets, rocket really shoots out there. Usually those are much higher numbers. C then is the starting height. So like in this case, I got a starting height of 14. That means someone was probably standing on something or like on top of a hill or something like that in a problem. If it's a person throwing it, you're going to see somewhere like 6 feet, 5 feet, something like that generally. For some of y'all, like 4 feet. But if it's a ball on the ground, because sometimes you'll see one where they kick, if it's on the ground, what's the starting height? 0. So you do see that sometimes as well. Okay? That just means there's no C value on it. All right, then. So when we have the function, all of those, I said we got a -A value, right? So all those have -A values. You don't always have a -A though. All right, so when we have a -A, like that one, gravity pushes down, you have a shape that looks like that. The parabola opens to the bottom. All right. When you have a positive A value, what that does is it flips it around. Obviously, the positive A value wouldn't work for throwing a ball because that'd just get higher and higher and all that. There are certain things, obviously, that would work for. The way I remember it easiest, if, let's pretend you're a positive person, you smile, right? If you're a negative person, frowny, right? To me, I don't know, that's the easiest way. Positive people smile, negative people frown. Positive A looks like a smile, negative looks like a frowny face. Make sense? Sometimes you have to match the function to a graph, and that usually eliminates two of the answer choices. Because like two of them will have the smiley face, two of them will have a frowny face. All right, so you need to label these parts on your pictures. If we have a smiley face, where it crosses the x-axis, they got two different names for that. They're either the x-intercepts, you don't see that one as often, or they are called the zeros. Basically, it's the value that makes the function equal to 0. Where it crosses the y-axis is, just like with linear functions, it's the y-intercept. It's also the initial value, the starting amount, all that stuff. Where these have something different from what we've done is when you get this little dot right here at the lowest point there, that's the vertex. So you'll see a lot of problems ask you for the ordered pair of the vertex. In the case of one that's a smiley face, that's the bottom number, so that's the minimum also. All right? So when it asks for the minimum specifically, a lot of times that's looking at the y value mainly, but they could be the whole ordered pair. Another one I didn't put on here, what you'll see sometimes is they're asking for the line that goes there, and what they call that is the axis of symmetry. All right, so cuts it in half. And what that is that's the x value for there, okay? So if you see axis of symmetry, it's asking for the x value of the vertex. Now, if you have the frowny face, it's pretty much the exact same thing. You have your x-intercept. You have your y-intercept, your initial value. And then you have your vertex. The only difference this time is when you have the vertex, instead of a minimum, it's a maximum. These are the ones that you see for when the ball is thrown. All right? So if we got the ball being thrown, we don't use that one there, and we don't use this part here. The part I crossed off to the left is because the y-axis is generally going to be time. And we're not time travelers. We can't go negative time, okay? So we got to have positive numbers for the x's. Similar idea, like when they're talking about throwing a ball or something like that, it's going to go like through the ground, so we're not going to get negative numbers for the height. What you have with this graph is then this is the starting height, like we were saying before. The y-intercept is the starting height, so C is also the y-intercept. This is the highest the ball would reach. So if it asks for the maximum height of the ball, it's looking at the y value for that. If it asks how long it takes to reach the maximum height, that's the x value. And then this final dot here on the right, that 0 there, that's where it hits the ground. So whatever that x value is there is when the ball hits the ground, or whatever's launched or thrown. Any questions on any of that? Then the other thing you'll see sometimes, and I don't have this on your thing, should be fairly obvious. We read things in reading, we go from left to right. Math, we generally go left to right. So when you have this part right here, that is where the graph is increasing. It's getting higher. Once it reaches that vertex, it starts decreasing. If it was the smiley face looking ones, it's flipped around. On the left, it's decreasing, and then once it reaches the vertex, it starts increasing. Okay? You know, usually, like I said, fairly obvious where it's increasing or decreasing kind of thing. All right, so you got basically 7 questions they can ask you. They can ask you for the axis of symmetry. The axis of symmetry, like I said, is the x value for the vertex. So I'll show you how to find that in a second. They can ask you for the maximum or minimum. That could be just the y value. That's usually what they're talking about, the y value for the vertex. The y-intercept, that's usually the easiest one. If they have the function, that's the c value. If they give you a graph, that's where it crosses the y-axis. The zeros, sometimes those are a little harder to get, but that's where it crosses the x-axis. How long the ball was in the air. So if it's one of those ball problems, if we're talking about like how long it was in the air, basically, you know, it's going from here to here, so your answer still matches like that 0. So it's still the same type thing, it's just you got to know which 0 to use. And then it asks for like the interval that it's ascending or descending. That's usually negative infinity to whatever x, or the x value of the vertex to positive infinity kind of thing. All right, so first thing we're going to do. This is how you find the x value for the vertex. Also, the axis of symmetry. So probably write this down on the bottom right there next to the one for axis of symmetry. This is probably the one you use the most on these types of problems. So you do the opposite of b over 2a. All that means is we're taking the b value, changing the sign. And we're putting it over 2 times the a value. So in this case, I'd have negative 64 over negative 32. Negative divided by negative is a positive. 64 divided by 32, in this case, gives me 2. That's all it is. Opposite of b gives me value maximum. Any questions on that? Opposite of b over 2a. That tells you how long it takes the ball to get to the maximum if it's a ball type problem. It tells you like just the x value for it if it's some other type of problem. So if we got the x value, we need the y value. So if it asks you for the maximum or the minimum, or if it just asks you for the whole ordered pair for the vertex, what you have to do is you have to do that opposite of b over 2a first. You have to get the x value. That's why that one's important, because even if it's asking for the y value, you still have to do it. So once you get the x value, which we got x equals 2, you plug it in to your function. So I'd have negative 16 times 2 squared plus 64 times 2 plus 12. All right, so then you got to do the math. Ideally, these would be calculator active, but they aren't always, okay? So we do exponents first. You know, please excuse my dear Aunt Sally, got to follow your order of operations. So 2 to the second power is 4. Negative 16 times 4 makes negative 64. 64 times 2 is 128, and we got plus 12. All right, so we can go left to right and follow our rules for negatives, or we can put the positives together first and combine the negatives, either way. 128 was 64 times 2 though, right? So if we got a negative 64, we're just taking away one of those 64s. That leaves us with 64. 64 plus 12 means we had 76 feet. So again, if this was somebody throwing a ball, after 2 seconds, the ball would be at a maximum height of 76 feet. Okay? 2 seconds, probably a long time for a throw type problem. You know, the ball doesn't stay there that long, usually. Any questions on that one? See how this works? All right, so the back of that sheet, we got some of these problems. We got a ball thrown off a 20-foot tall building with an initial velocity of 32 feet per second. We need the function of the ball, or that shows the height of the ball after t seconds. So for the height, when it's asking for the height, what the height is just your y value. So you could have h equals, you could have it with the function notation where it's like h of t equals. Either one would work, okay? All right, so what's my gravity? What number I use? Negative 16. We got feet, so in most cases they give that to you, but you know, there's a couple times I've seen where they haven't. So the negative 16 goes as our a value in front of the x squared. What goes in front of the x? What should I put in front of the x for the coefficient? 32, the initial velocity. So initial velocity goes in front of the x, and then our starting height, or initial value on the height, is our c value. So there's our function. Now, it says how many seconds, or after how many seconds did the ball hit the ground? 0. Finding a 0, what we're doing is first going to factor problem, okay? So I've got negative 16 plus 32x plus 20. I can get a 4 out of that, right? 4 goes into each one of those numbers. What I'm going to do a little bit differently, I'm also going to just take out a negative 4, okay? It makes things easier to factor if your a value is positive, okay? So since I got a negative 16, if I factor out a negative 4, that leaves me with 4x squared. Then I've got minus, because it's going to change the signs on these when I factor out that negative, 8x and minus 5. Okay? Everybody good with that step so far? All right, so now what we're looking for is, you know, if we're doing our x, we're looking for what multiplies to make negative 20 and what's adding to make negative 8. So the sign's got to be different, right? Bigger numbers got to be negative. What that's going to give me is negative 10 and positive 2. Negative 10 times positive 2 is negative 20. Negative 10 plus 2 would be negative 8, okay? We divide by the coefficient, okay? So our a coefficient, we use what's here after we factored it out. We're going to use the positive 4. So that one simplifies to 1/2. Have to go the other way. That one simplifies to negative 5 halves. All right. Everybody okay with that part? So if I were to write that factored out, based on what we were doing before, I'd have 2x minus 5 and 2x plus 1. We got the negative out in front. Everybody okay with that part? All right, so here's the thing. We don't need that for finding the zeros. We don't need this part right here. All right. What we need are these two numbers here. Those are almost my two zeros. So the difference between factoring it and finding the zeros is changing the signs. So when I'm looking for the zeros, what I do is I factor it just like I did here, but I need to change the signs. All right, so that gives me a positive 5/2 and a negative 1/2. Everybody kind of follow on that? You got to change the sign to find the zero. All right, so the ball is going to hit the ground after 2.5 seconds. Who's not sure where I got 2.5 from? All right, so when you change the signs, like I said, we can't have negative time, right? So we got to use the positive value. So in this case, that becomes the positive value. So that's when it's hitting the ground. And then, you know, generally time you'll see as a decimal, not a fraction. All right, so now we need the highest height that ball reached. So what do I have to do first to find the maximum height? Get the x. How do I get the x? Opposite of b over 2a. So if I'm doing opposite of b over 2a, I use the equation we got to start with. So my opposite of b is 32, or negative 32. My 2a, 2 times negative 16, also negative 32. So negative 32 over negative 32, that's an x value of 1, not the answer. When it asks for the highest height, that's the y value for that vertex, okay? So we got to plug that in. The good news is 1's usually, obviously, you know, very easy to work with. We got negative 16 times 1 squared plus 32 times 1 plus 20. 1 squared, 1 times 1, that's just 1. Negative 16 times 1 obviously is negative 16. 32 times 1, 32, plus 20. Negative 16 plus 32 is 16. 16 plus 20 gives me 36. That'd be the answer for there. Needs to get a little more complicated then, don't they? Any questions on any of those? All right, let's look at another one then. This time we got a rocket. Rockets go a little faster. So first thing, just like the other one, we need the function. Who can tell me what function to use for this one? We got a rocket at the top of a 180-foot high hill. Has initial velocity of 96. We needed our function. So once you got the function, raise your hand. And we'll use H and T again. Rick? I don't know if I heard for sure, but negative 16 x squared plus 96x plus. Any questions on that? I couldn't hear if it said negative for sure or not, but gravity, we need that negative, okay? All right, so now we need to know when the rocket hits the ground, okay? What number goes into all of those? 4 does. 2, 8. 16. All right, so I can factor out the negative 16, okay? So if I factor out the negative 16, that's giving me a positive x squared minus 6x minus, oh no, I was wrong. 16 doesn't, 8 does. No, 8 doesn't either. My bad. 16 does not. 16 would have made it a lot easier. So we'll go with the negative 4. So we got 4x squared minus 21x minus 45. So when you do this, what you're looking for, you got 4 times 45, so you're trying to make negative 180, and it's going to add to a negative 21. So you got different signs, bigger number is going to be the negative. So go ahead, find where that ball is hitting the ground, or rocket. This one's a rocket. So as I said, we're looking for the negative 180 and the negative 24. So in this case, what we're going to have is you would have negative 30 and you would have a positive 6. We divide by our coefficients. Our coefficients are 4. For zeros, though, which is this is looking for, we change the signs. So the 30 over 4 becomes my positive, 6 over 4 becomes my negative. So 30 over 4 is where it hits the ground, because that's the positive 0. We got to simplify that. 30 over 4 could simplify to 15 over 2. 15 divided by 2, if we put it as a decimal, that's giving us a 7.5. Any questions on that one? Yeah, my bad for misdividing to start with. So when does the rocket reach the maximum height? We'll do that part first. So we're looking for when it reaches the maximum height. What you got to do there is your opposite of B over 2A. So go ahead and give that a try. Opposite of B over 2A. So you do opposite of B over 2A. And we got Evelyn? 3 is correct. So when you plug the stuff in, you got negative 96 over 2 times negative 16. So that's negative 96 over negative 32, right? Everybody okay with that? Now, just to show you, this part here, if I did it with that and put my opposite of B, that'd be positive 24 over 2 times A. 2 times A is 8. You got 24 over 8. That still gives you 3. So if you use the factored out version, sometimes that'll be easier numbers to work with, okay? Just be aware. All right, now we know how high. So what do we do to find how high? In, you got negative 16 times 9 squared plus 96 times 3 plus 180. Now, a little bit bigger numbers to work with on a problem like this with, rocket being launched and all that. But when you do your math there, you get a 324. Okay? And then the last part, it's asking how or over what domain the rocket's height is increasing. So at what time do we start launching the rocket? What's the time at that point? When the rocket launches, what's the time on the timer say? 0, yeah. So we're going from 0 to reach the highest. Nope. 3. That's the x value. We're looking at x values, okay? So that is where it is increasing, okay? If we're looking for the interval that it's decreasing, at what time does it start decreasing? 3. It goes up until it gets to 3, then it starts decreasing. When does it stop decreasing? 7.5, yeah, it goes splat, right? Or boom, or whatever the rocket does. Right? Y'all follow how those domains work for increasing or decreasing or ascending, descending? It's going from where it starts off. If it wasn't a throwing problem kind of thing, you infinity to 3. Since time matters, we go 0 to 3, and then it's 3 till ground. Okay? Any questions? A little more complicated than the stuff we've been doing, right?